Namaste. I welcome you all for the on behalf of Vigyan Bharati Pune. As you all know, we meet every Sunday through this platform with new scientific subject and try to establish Vijnana Samvad. Many of you might be aware that Vigyan Bharati organizes India International Science Festival along with the Ministry of Science and Technology every year. Today's session is part of Vigyan Yatra for IISF 2020 and it is outreach and publicity activity for IISF. I request Shri R.V. Kulkarni, President of Vigyan Bharati Pune, to give welcome address.
नमस्ते सभी विज्ञान प्रेमी श्रोतृगण को मेरा सादर प्रणाम। विज्ञान भारती पूरे देश के स्तर पर छठा भारतीय अंतर्राष्ट्रीय विज्ञान महोत्सव 22 से 25 दिसंबर तक आभासी रूप में आयोजित कर रही है। इस महोत्सव के उपलक्ष्य में आज का ये कार्यक्रम आयोजित हो रहा है। आज के कार्यक्रम के प्रमुख वक्ता प्रोफेसर डॉक्टर विनायक सोलापुरकर, आदरणीय श्री प्रसाद जी कुट्टम, जो विज्ञान भारती पश्चिम बंगाल और झारखंड के संगठन मंत्री है, मानसी जी और विज्ञान भारती के सभी सदस्य और श्रोतृगण। कार्यक्रम की शुरुआत में विज्ञान भारती के बारे में संक्षिप्त जानकारी लेंगे। विज्ञान भारती केवल एक अखिल भारतीय संस्था नहीं है, बल्कि यह राष्ट्रीय स्तर का सभी समाज को साथ लेने वाला वैज्ञानिक आंदोलन है। पाठशाला से विश्वविद्यालयों तक विद्यार्थी, संशोधक, शिक्षक, वैज्ञानिक, तंत्रज्ञ और विज्ञान में रुचि लेने वाले सभी सामान्य जन इसमें शामिल है। विज्ञान को सभी स्तर में ले जाने का काम विज्ञान भारती पुणे 25 साल से ज्यादा समय तक कर रही है। इस संस्था की कुछ विशेषताएं हैं। अपने देश को बड़ी ऐतिहासिक, प्राचीन, सांस्कृतिक और वैज्ञानिक परंपरा है। प्राचीन काल से वैज्ञानिक प्रगति हम करते रहे हैं। इस पारंपरिक विज्ञान में प्राचीन ग्रंथों में भी हम रुचि लेते हैं और इसका अभ्यास आधुनिक विज्ञान के तरीकों से हम करते हैं और उसको सभी समाज के सामने ले जाते हैं। भारत की एक विशेषता है कि इसमें विज्ञान को बहुत कुछ जोड़ लिया है। जैसे अध्यात्म विज्ञान भारती मानती है कि विज्ञान का एक हिस्सा है। योग है, वेद है, शिल्पकला है, ललित कला है, गणित है, खगोल विज्ञान, आयुर्वेद, खेती, वैज्ञानिक उपकरण, निसर्ग निरीक्षण, सभी नेचुरल साइंसेस आदि सब विषयों को वैज्ञानिक अध्ययन हम सैकड़ों सालों से करते आ रहे हैं। किंबहुना इसके बहुत क्षेत्रों में हमारी खास विशेषताएं भी है। इसे पूर्वापर वैज्ञानिक प्रगति का अभिनिवेश नहीं, लेकिन अभिमान जरूर है। सभी वैज्ञानिक विषयों का अध्ययन अपनी देश के उन्नति के लिए, आत्मनिर्भर भारत बनाने के लिए आवश्यक है। पर्यावरण, पानी, प्रदूषण, ऊर्जा, आरोग्य, जैव विविधता, जैविक कचरा व्यवस्थापन, ग्रामीण भारत की समस्याएं, कृषि क्षेत्र की समस्याएं, इन सभी विषयों में संशोधन होना देश के प्रगति के लिए हम जरूरी मानते हैं। विज्ञान भारती विद्यार्थियों का वैज्ञानिकों से जोड़ने में मदद करती है। विज्ञान भारती देश के मशहूर वैज्ञानिक, तंत्रज्ञ और उद्योगों से जुड़ी हुई है। इन सबका सहाय्य विद्यार्थी और अभ्यासकों के लिए मिलने में हमारे परिश्रम चलते रहते हैं। विद्यार्थी विज्ञान मंथन नाम की प्रतियोगिता पाठशाला में राष्ट्रीय स्तर पर आयोजित की जाती है। इसमें जो विद्यार्थी चुने जाते हैं उनको केवल शिष्यवृत्ति नहीं मिलती, लेकिन उनके रुचि के विषय में मशहूर वैज्ञानिकों से उनको जोड़ा जाता है और उनको संशोधन में मदद की जाती है। वक्तृत्व, निबंध, प्रकल्प प्रदर्शन आदि माध्यमों से विद्यार्थी विविध उपक्रम में हिस्सा ले सकते हैं। महाविद्यालय और विश्वविद्यालय के छात्रगण छोटे मोटे संशोधन प्रकल्प और अन्य प्रतियोगिता में भाग लेते रहते हैं। वैज्ञानिकों को विद्यार्थियों तक पहुंचाने में हम सहायता जरूर करेंगे। शुद्ध मूलभूत संशोधन और तंत्रज्ञान प्रगति के लिए जरूरी है। इसके लिए हम हमेशा प्रेरणा देते रहते हैं। मुझे उम्मीद है कि आप सभी लोग विज्ञान भारती के विविध उपक्रमों में जरूर हिस्सा लेंगे और 22 से 25 दिसंबर तक आभासी तरीके से होने वाले भारतीय अंतर्राष्ट्रीय विज्ञान महोत्सव में आप जरूर शामिल होंगे। मैं विज्ञान भारत की तरफ से आज के वक्ता डॉक्टर विनायक सोलापुरकर, श्री प्रसाद जी कुट्टन, इनका भी स्वागत करता हूं। सभी श्रोताओं का स्वागत करता हूं। नमस्कार।
धन्यवाद सर for this brief about Vigyan Bharati and the activities which Vigyan Bharati organizes. Let us now understand about this India International Science Festival and also about this Vigyan Yatra. I request Shri Sreeprasad ji to enlighten us. Shri Sreeprasad ji is full-time volunteer worker of Vigyan Bharati since 7 years. Academically, he has completed his engineering in computer science. Then he has also worked in IT industry for about 4.5 years as a software developer. He is dynamic full-time worker and currently organizing secretary of Vigyan Bharati West Bengal chapter as well as Jharkhand chapter. And his Kendra is Kolkata. Over to you, Sreeprasad ji.
धन्यवाद मानसी जी। आज ये विशेष कार्यक्रम में हमारे साथ उपस्थित विज्ञान भारती पुणे चैप्टर का आदरणीय कुलकर्णी जी और आज इस प्रोग्राम का मुख्य वक्ता प्रोफेसर विनायक जी और बाकी सब विज्ञान भारती कार्यकर्ता और इस प्रोग्राम देखने वाले सभी बंधुओं को मेरा सादर प्रणाम। Today is we are organizing this. Actually, I am feeling very proud to be part of this Vigyan Samvad, which is organizing by our Pune chapter. In this lockdown period, we started so many programs, and always I was in the backstage to organize all these programs in Vigyan Bharati Sunday Live Talk series, and even Pune when they started this program, I also helped to organize these programs. So today I got a chance to come in the front stage and to interact with all of you. So I'm very feeling proud today. So in this Vigyan Samvad, today we are organizing this program as a Vigyan Yatra Karikam, the Vigyan Yatra of Indian National Science Festival 2020. What is Indian National Science Festival? And what is the main Uddesh? What is the main agenda of this program? And why we are organizing this program? And what is this Vigyan Yatra? So I would like to just give some idea about all this. All these things. What is Indian National Science Festival and what is Vigyan Yatra and what is the importance of this all these programs. All of you know that Vigyan Bharati is a big organization working for this popularization of science and technology. And sometimes the main agenda is that our nation's development through the integration of science and technology. Mainly scientists, technocrats, those who are loving science and technology, all they are part of this movement, and we are working with a Swadeshi spirit. What type of science is developed in our country, and how we can give that message of science to everyone in our country. That is the main objective of Vigyan Bharati. So, keeping this idea in our mind, Vigyan Bharati designed one program, that is India International Science Festival. That is 4 words: India International Science Festival. What is the connection between all these 4 words? And why sometimes people, when we designed this program in 2015, people started to ask this question: what is the connection between all these 4 words, India and what is international, then science and festival? for different and for, beginning we will not get an idea what is the connection between India and the international, then science and festival. What is the relation between science and festival? Where this science is connecting with the festival. So we try to explain our programs or our all these events and initiative how we are taking science in a festival mode, and through these festivals how we are reaching science into common masses. And through this program, we are saying India's achievements to the world. That is the connection of, in between these four words. We have to show our achievements, our country's achievement in the field of science and technology to the world. We are showcasing our achievement to the world through this program, India International Science Festival. And we are celebrating science in a festival mode. It's a celebration of science. In this celebration, we are reaching to crores of people. We are giving the message of science to crores of people in a festival mode. In a festival, there is no issues to anyone to come and participate. Always we are have a feeling science is a very difficult subject. Science is a very difficult to learn, difficult to practice. So we are removing that concepts. We are taking into a festival mode, in a fun mode, in a fun festival also. Through this festival also we can understand science, what type of achievements happening in our country, what type of research happening in our country. Everything we can understand through this International Science Festival. So that is the brief idea about International Science Festival. And through this festival, what we want to showcase the to world, what is our heritage in science and technology. As today is in this Vigyan Samvad of the Vigyan Samvad program, our subject is ancient mathematics. What is our heritage in the field of mathematics? What is our nation's heritage? We all know that from the Vedic period, we are a rich heritage in mathematics. We know this Sulba-sutras, which is composed in this 800 BC by Bodhayana, or uske bhaat in the Middle Ages, or post-Vedic period में contributions in the field of algebra by Aryabhata or Brahmagupta and the Middle Ages. And and when today I'm talking in this time, I'm feeling proud. I'm coming from the village which is belongs to Sangamagrama Madhava. In my school studies or college studies, I don't have any idea about Sangamagrama Madhava, who is now known as a great mathematician. I don't have any idea in my schooling time. But when I ended in Vigyan Bharati, when I am attending Vigyan Bharati's program, I get to realize that I'm coming from a village where Sangama Grama village, hardly 20 meters from my own house to the village which is called Irinyalakuda in Kerala, where Sangama Grama Madhava lived in the Middle Ages. And when I studied the Lebanese series, I didn't know that the concept behind Lebanese series is the contribution of Sangama Grama Madhava. Now this series is known as Madhava Lebanese series. So in this time when we are entering this field of when we are searching about the contributions of Indian mathematicians and in any other field of science and technology, we have a rich heritage. Professor Vinayak is here. Vinayak can explain very well about this, our contribution and Indian mathematics or Vedic mathematics. So I'm also very eager to listen that. So we have all this rich heritage, and even this modern age also. We have wonders like Ramanujan. We have wonders like Shakuntala Devi. Recently, one film is also released about Shakuntala Devi and Ramanujan. So when we are watching that movies, when we are studying their contributions, we are just feeling wonder on all these things. So through this program, International Science Festival, we want to showcase all these things to the world. These things happened in India, and in this period also, it is in our current period, modern ages also. We are behind no one. We are always in front runners in the field of science and technology. So through this International Science Festival, we want to showcase all these things to the world. And same time, we have to include everyone in our country. Each and everyone should come into this platform and how to understand that. So from when we are organized International Science Festival in 2015, we had around less than 15 events were there. Young Scientist Meet, Mega Science and Technology, like that. Some events were there. Around less than 10,000 delegates were there. But gradually, this program is increased. 2016, we again conducted International Science Festival in Delhi. After that, in Chennai, then Lucknow, and last year in Kolkata. So all this every year, when we are organizing this program, we are thinking that how we can include more people in this platform. From this 10,000 delegates to this year. Yesterday, when we are checking, around 1 lakh people are registered for this event. In this pandemic situation also, Vigyan Bharati has never stepped back. We are always trying to reach out people through this new virtual platform. We're taking this International Science Festival to a new dimension. This time we are arranging this program in a virtual platform, which is a unique concept we are organizing. It's not like a simple Zoom meeting or a simple Google Meet. You will get a feeling like that you are entering into a festival venue. You are entering in a big convention center. You can walk through that corridors. You can enter in the halls. You can sit over there and you can attend. This is a unique feeling you are going to experience this time. And in this program, we are inviting everyone, each and everyone in our society, from the student who is studying in the sixth standard to the students doing the research in premier research institutes in India. For students, we are organizing Science Village, Guinness World Record programs, Young Scientist Conference, like that, students to young scientists, and scientists to global Indian scientists, those who are working in Indian labs, premier Indian labs, they're working, and the scientists, those who went to abroad, and those who are working in the premier institute in other countries. So for them, we are organizing the program. Women scientists, we are inviting the women scientists to Women Science Conclave. We are inviting the farmers in our country. They are the real developers in our the contributors in development in our country. We are inviting the farmers in our platform, and we are giving a chance to talk with the scientists, those who are working in the agricultural universities, agricultural research institute. They are they are discussing their problems. Scientists, they are telling their solutions to them. Same time, they are taking the input from the farmers to what they have to do in the getting input for their research. So all this way, and you can imagine that is a big platform. This 20,000, 40,000 people are coming together with a single agenda. There is, you can wonder, this year or last year also, we invited the science writers, those who are writing science fiction, those who are seriously writing science subject. They are coming over there. The performing arts, this year new program is there, performing arts and science. People are invited from the performing arts field and discussing about science. And we are inviting this people, those who are thinking about philosophy of science, those who are making the history, writing about the history of science. The various subjects, various events, 40 events in the year of 2020, they are coming with 40 events in International Science Festival. And through all this program, what is our agenda and what is our theme in this International Science Festival? Our theme is the self-reliant Bharat, Atmanirbhar Bharat, through science and technology. With the contribution of science and technology, a self-reliant nation, our country should reach into the self-reliant position, and that will be provided global welfare. Self-reliant Bharat through science and technology and global welfare. No other countries can have this concept like this. When our country is progressing, how it will provide a global welfare? How we can be part of a global welfare when we have become a self-reliant nation? In the post period, we know that our country have that culture where we never invaded anywhere, we never attacked anyone. We always be like a Vishwaguru position we had. We giving a margadarshan to all countries. So we want to achieve again into that position. Our country should reach into this self-reliant position, Atmanirbhar Bharat, and that will provide a global welfare. That is not only Vigyan Bharati's dream. It is a dream of our sages, our rishis, our munis. All they have this dream. Our country will come back. Even when I come from Kolkata, Swami Vivekananda had this dream. So our country should reach into that position, and we will lead the world one day. So it will come back again. That situation will come back again. So this is a journey towards that goal. So science and technology have a big contribution, should have a big contribution. No other country, any country will not develop without a contribution of science and technology. Our country also have a big contribution in the field of science and technology. So this International Science Festival is a one part of that journey to that big goal. Through this program, we can experience this the achievements of our country, and we can all part of this program. And this year, in this pandemic situation also, we can come together in this virtual platform from 22nd to 25th December. 22nd evening, 4 o'clock. Our Prime Minister, Adharaniya Narendra Modi ji, is going to inaugurate this program. And in Valdity session, our Uparashtrapati Adharaniya Venkaiah Naidu ji will address also. So in this 4-5 days, we will come together as part of this promotional activities. We are conducting this Vigyan Yatra. Lots of program. Today we are conducting more. I think it is 235 program we already conducted. This is the 235th program. So in this program, we are reaching in each and every corner of our country, and we are talking about science. Today, we are talking about ancient contributions of contribution in field of ancient mathematics, and other subject. Every nook and corner of country, we are talking about science. So we are bringing everyone together using one single word, that is science. Through the development of science and technology, our country will reach into that self-reliant position. So once again, I'm inviting everyone to this International Science Festival virtual platform from 22nd to 25th December. I hope everyone will join over there and we will meet over there. Thank you.
Thank you, Sreeprasad ji. It was a very nice and elaborate information about India International Science Festival, and definitely people will join. Now let's move ahead and listen to Dr. Vinayak Solapurkar, sir. Dr. Vinayak Solapurkar is in charge principal of SP College Pune. He is well-known mathematician and he is teaching for last almost 35 years. He is member of BOS for mathematics in Savitribai Phule Pune University, Symbiosis, Chogule College, Somaya College, and so many others. He also is elite member of local management committee of SP College. His research interest and specialization is in operator theory, functional analysis, and differential geometry. He has published many research articles in reputed journals and also have guided PhD as well as MPhil students. He is a very beloved teacher amongst the students. So without taking much time, let us now listen to Sir on ancient Indian mathematics.
Thank
Over
you,
to
Manasi.
Solapurkar, sir.
Respected Sukumarji, respected Professor R.V. Kulkarni, he is my teacher when I was in Garware College. All other office bearers of Vijnana, Bharati, and dear friends. At the outset, I thank Vijnana Bharati for providing me opportunity to interact on ancient Indian mathematics and also to contribute in this small way in this big event, India International Science Festival. Sukumarji very nicely and he elaborated on what this festival is going to be. And I'm happy that I could have my share today, and then our college, our students, and the periphery, we will try our best so that it will reach to all the student community in Pune, and Pune people and students will wholeheartedly join this India International Science Festival. I'm further very happy about what Sukumarji just now told, that he comes from the village where Madhava lived, Sangamagrama. So we will get some chance maybe towards end to talk about Madhava also. Incidentally, Sukumarji, we have been running a competition called Madhava Mathematics Competition for last 10 years, and SP College is started this competition with some few students from Pune and Mumbai. Now it has become a national level competition named Madhava Mathematics Competition, just to know the at least Indian people to start with, and then the rest of the world, who was Madhava and what are contributions of Madhava. And now it is conducted in 23 regions in the country, and about 10,000 students participate in this event. It is named after this great founder of the Kerala school, Madhava. And this is first time that is somebody closely connected with Madhava I am talking in front of. So I am very happy about the presence of Sukumarji today. Let me share my presentation and talk for about 40-45 minutes on contributions of ancient Indian mathematics. So let me share my screen. I hope you can all see the screen. Yes, Manasi? Hello?
Yes, sir. We can see your screen.
Okay, fine. So I am going to talk about ancient Indian mathematics today. So let's start. Outline of the talk is that we'll briefly survey Indian mathematics from Vedic period to Kerala school. We just talked about the Kerala school, and Sukumarji also mentioned about the Vedic period. One has to talk very briefly on this because the span is so vast and it is difficult to cover the entire spectrum in whatever 1 hour or even 1 week. So it's a very vast amount of work that Indian mathematicians have carried out in this particular period. So we will just take a tour and give highlights of Indian mathematics in this particular lecture. Towards end, we shall talk about Ramanujan, the pinnacle of Indian school. Though the title is ancient and Ramanujan comes from modern period, but I think that the culmination of this mathematics that was developed throughout this entire whatever more than 2,500 years, Ramanujan was one of the greatest mathematicians that India has ever produced. So towards end, we'll pay our tribute to Ramanujan, and incidentally, 22nd December is his birth anniversary. So we'll get a chance to talk about Ramanujan towards the end. I will try to present the work in the chronological order, but sometimes there could be change in the order as well if it demands. In this lecture, it is not possible to contain the proofs of the mathematical statements, because suppose one wants to give proof of any mathematical idea that our ancient Indian people delivered, then that itself will take more than half an hour or whatever. So I want to just give the contributions without proofs, and but I will give references where you will be able to find the proofs of the mathematical statements. Okay, roughly the timeline is like this, that is given in this table. So even before Vedic period, there was some mathematics, of course, at a practical level, due to day-to-day, demands. People had to develop some mathematics in terms of weighing machines or some computations in terms of geometrical figures to divide the land and so on. Then comes typically the Vedic period, and towards Vedangas, where Sulba-sutras were developed by Buddha, Apastamba, and Atyayana. Then there is Jain period. Then there is, so I have listed it here, you can see. The important period is 400 to 1200 Christian era, and where this great mathematicians like Aryabhata. Then there are some books are mentioned there. There is something called Bakshali manuscript. We are going to talk about that. Lilavati, of course, Vijayanita. Then comes Kerala school, Madhava, Parmeshwara, Nilakantha, Jeshtadeva. And then all of us know about Ramanujan. So roughly, this is the timeline that we are going to follow in this lecture. Now, before we begin with actual mathematics that was done by Indian mathematicians, it is important to look at the Sanskrit tradition, because mathematics was presented in this particular Sanskrit tradition, and it has some bearing on how mathematics was developed in India in ancient period. So as compared to the contemporary writings, personal or biographical accounts are less in Sanskrit tradition. So this is one of the highlights of Sanskrit tradition, that you will find very less biographical notes or personal comments. Okay? And then as a history, it becomes therefore difficult after thousands of years to dig up the matter. So this is one particular thing that we will see in Sanskrit tradition. There are very less biographical notes. Then in Sanskrit writings, ideas about the reasoning, this is a very important point that we should note. Ideas about the reasoning and reality are directly linked to Vyakarana. So Vyakarana and the Tarka Shastra that comes out of it, the logic that comes out of the... so Vyakarana was more important as compared to the Greek period, where you will find deductive reasoning and the observations coming from the nature and put in mathematical world was taken up as the final or standard reasoning or reality, is not directly found in Sanskrit writing. So mathematical knowledge was not a standard way of arriving at an epistemic certainty. So epistemic certainty was through another philosophical means, especially this Vyakarana and Tarka. And then mathematicians had to go through this particular route of writing in this fashion. So you will see all the mathematical writing that goes in this particular Sanskritized tradition. The idea of mathematical proof was different from formal chain of deductive logic. That's what I mean. So formal chain of deductive logic as explicitly evident in Greek period. However, there is a totally different and innovative method of giving the proof, which will come to that later. So in fact, that is one of the great achievements of mathematical thinking in India. It is totally different from what comes from Greek, that is especially Aristotle's syllogism or the deductive method of proving things. So this is kind of background that we need to keep in mind when we look at mathematics from ancient period. Then we come to Vedic period, where that is roughly this period I think of as Vedic period. It contains a wealth of knowledge on variety of subjects. It includes knowledge especially on philosophy, many sciences including mathematics, astronomy is very dominant in this, even music, many fine arts. So you will find wealth of knowledge in this period. Just as a token, in Indra Sukta, there is concept of multiplication you can see. So Trisapte is 21 actually, and this Indra Sukta is about the Indra, and 21 times Indra has defeated the enemies. That is written in the just as a fun. I am showing this. The main thing in this Vedic period is decimal system of number word. So numbers were not the numbers that we see today, but the number word. Some word will depict a number. Some word will code a number. Okay, and these coded words will be numbers actually. So there is a clear mention of 20, 30, 40, which indicates the decimal system. Okay, so in the description of horses of a chariot, these numbers are clearly mentioned there. Also, 3,339 gods have been mentioned in the Rig Vedas. So this mention of the decimal system, but by using words, we are going to see those words later. And in the Middle Vedic period, we will find words for large powers of 2 also. So they go up to 10 to the power 12. We are going to see in a tabular format later the names of the words that are given to this 10 to the power 12. So the main contribution I would say in this Vedic period is the development of certain operations, certain arithmetic on numbers, and those numbers they could think of in the decimal forms. Okay. Okay, here you can see in Yajurveda clearly gives the large powers of 10. I will give you some time to read this if you want. This is a direct reference from Yajurveda. And these are powers of 10. Shata, Sahasra, Ayuta, Niyuta, Prayuta, Arbuda, Nirbuda, Samudra, Madhya, Anta, and Paradha. So Paradha is 10 to the power 12. So if you read some Sanskrit stanza like it is quoted here, one has to first of all decode it so that these words are these numbers actually. So one has to very carefully draw meaning out of this mathematics written in this Sanskrit format. Okay. Continuing with the Vedic period. Well, if you look at this earlier slide, then they go up to 10 to the power 12. Now the question is, in day-to-day life, you do not need very, very large numbers as such. Okay, and especially this is more than 2,500 years back. Okay, so there are speculations about constructing the large numbers. Why Indian mathematicians would have constructed such large numbers? And the reason, to my opinion, is obvious. They could be engaged. The reason could be engagement of Indian mathematicians in the study of universe. So they were behind this celestial measurements, and then therefore they wanted some units of large numbers, and therefore these large numbers must have been constructed. Very interestingly, in Upanishads and contemporary Buddhist and Jain writings, one finds the mention of the word sunya. There is some kind of emptiness they wanted to show, and then that resembles something to what we call as zero, as well as there is mention of purna, and that purna is written for infinity as such. So the notion of infinity was there in the minds of ancient Indian mathematics, which is of course evident from other sources also. But these two particular words appear, sunya and purna. We are going to see this purna later on. Then decimal system in number words and fascination for infinite quantities therefore is apparent in this Vedic period, especially in the middle Vedic period. The thrust was on expressing the numbers in decimal form, using these numbers to have some measurements in the astronomy. Remember, astronomy has been a kind of the mathematicians were more behind astronomy. They were fascinated by the sky and they wanted to know more about it. Okay, we are going to see some books written on astronomy later on, Jyotish Sara Sangraha and things like that. So major area of interest was definitely astronomy, and Indian mathematicians excelled in astronomy. They predicted eclipses, they measured certain distances. We'll get chance to see that. Interestingly, this Vedic period, the computation of the Vedic period, the period in which this what we exactly call as Vedic, Lokmanya Tilak has written a very scholarly book, Arctic Home in Vedas, which attempts at determining the period of Vedas based on astronomical researches. So the development of astronomy in a certain period and the sky that they must have seen at that time, you can have some kind of backward tracing and see and compute the period of Vedas. So this particular very scholarly exercise has been done by Lokmanya Bal Gangadhar Tilak in his book Arctic Home in Vedas. All the students present here, I just appeal that this book is available. This book is available on Amazon, in fact at a very low cost, and it is worth reading this book. That will give you a chance to think about Vedas and relation of astronomy to Vedas also, and also to see the contribution of Lokmanya Tilak, who is more known as a political leader, freedom fighter, and okay, but then he was very scholar in Sanskrit as well as mathematics, and this book definitely vouches for that. Okay, I was talking about this Purna, and all of you know this. Purnamada, Purnamidam, Purnat, Purnamudachyate, Purnasya Purnamadaya, Purnameva Vashishyate. This comes from Shukla Yajurveda. And this clearly means infinity can come out of infinity only, and infinity is left over from infinity. So today in fashionable modern mathematics language, we talk about operations on extended real number system or extended number system. So number system as such does not include infinity, but if you have a theoretical extended number system which includes infinity, then there are certain, one has to define operations on infinity. And you can see right here in Ishopanishad, they say that infinity can come out of infinity only. Infinity is left over from infinity after operations on it. Very interesting. From infinity is born infinity, and when infinity is taken out of infinity, only infinity is left over. So it is very clear that in that period, uh, either by looking at the sky or by looking at the number systems, they realize that there is a some notion of infinity has to be put in the scientific world, and now it is very prominent, especially in pure mathematics. You cannot go away by you have to study many notions in the neighborhood of infinity only, because the mathematical world is full of number systems which are infinite in nature, and infinity is a kind of compulsory study in the modern mathematics. But one is amazed by the thoughts in the early Indian period, They have given very clear thinking on infinity, I suppose. Then comes Sulba-sutra. Sukumarji was talking about Sulba-sutras in ancient. So these are famous books, and there are some clear. This is kind of first evidences of clear-cut writings and derivations by Indian mathematicians, and some important formulae evolved in this Sulba-sutra. Sulba-sutra means rules of chord. So shapes of an altar motivated the study of several geometrical figures. So if you take a chord then and form a certain shape, and then form an altar from those shapes, but then you can change this figure to some other figure and construct some other geometrical figure. So there is some transformation in today's language, transformation of one geometrical figure into some other geometrical figure, where facilitated by these rules of chord. So clearly, square, triangle, circle, etc. were studied in Sulba-sutra. There is absolutely no doubt. These figures have been mentioned in Sulba-sutra. In fact, you will see that geometrical formulae like area of triangle, area of square, approximately area of circle, then transformation of one figure to the other, even area of trapezium, and many constant. So very famous constant is pi. So they are thinking about this mathematical constants also in this Sulba-sutra. So Sulba-sutra can be thought of a major contribution in this ancient period, where you will be able to find a rigorous treatment of important geometrical concepts like mensuration, and there is arithmetic also in Sulba-sutra. So the four main Sulba-sutras are attributed to Buddhayan, Manava, Apastamba, and Katyayana. We find units indicating human body parts like Anguli. So in Sulba-sutra, you will find units which come from human body. Half of the hand, full body height, okay, proportion of legs to the entire height. Something like Anguli words you will be able to see in Sulba-sutras. Then these sutras give area preserving transformation. So this is modern language. Just to link you to the ancient period to the modern language, I have at times used this language. So area preserving transformation from plane to plane, if you think, or space to space. Then triangle can be transformed to square, square into trapezium, and so on. So that was very easy by using these rules of chord, and therefore these mathematicians in Sulba-sutra period have actually written those transformations, how to go from one geometrical figure in plane to other geometrical figure. Now this is very, very striking and very important. In Buddhayan Sutras, this so-called Pythagoras theorem is clearly given with a proof. So proof of Pythagoras theorem can be found in Sulba-sutras, and they knew that if you take hypotenuse and square and construct a square on the hypotenuse, its area is equal to sum of the areas on the squares constructed on the sides. So many years, this school books, at least in Maharashtra I saw, gave a proof of Pythagoras theorem based on area. There are several proofs. So for students present here, let me tell you that there is a book called 365 Proofs of Pythagoras Theorem. Okay, that is every day you get up and read a proof of Pythagoras theorem. Next day again read some other different proof of Pythagoras theorem. And this is one statement that has fascinated many amateur mathematicians also. So many politicians, like some ex-president of America also has given once a proof of Pythagoras theorem. Many mathematics clubs, they keep giving new proofs of Pythagoras theorem. But what we call as Pythagoras theorem, okay, that comes in Buddhayan Sutras. So that is before the Pythagoras. So Pythagoras came over 450 BC. So Buddhayan Sulba-sutras came before that. And the proof of Pythagoras theorem can be seen in this. Several geometrical constructions like constructing isosceles trapezium figures with desired proportion of area from one given. So suppose you have been given a square, then construct another square with 1/3 area, or construct other geometrical figure with area 1/3 of that. So some proportionate areas figures with those areas can be constructed, and all these geometrical constructions, which are actually good geometrical transformations in today's language, that been given in Sulba-sutras. Circle is also studied. In studying circle, one interesting thing happens, that it is not a figure bounded by straight lines, so it's a curvilinear figure, and as soon as a curvilinear figure enters, yeah, you naturally hit pi, and pi is a mysterious constant. And from all this ancient period to even today, people want to calculate the decimal expansion or further and further decimals of pi, because pi is a transcendental number with no, therefore there cannot be any finite decimals or even recurring decimal. So as many decimals you find, it's a kind of industry, so people are interested. Many great mathematicians are also very interested. Towards end, we'll see Ramanujan was very much interested in computing decimals of the pi and so on. Okay, so this Indian mathematicians also, therefore, while studying circle, because they wanted to transform square into circle or circle into square, so in this transformation they have computed some value of this constant pi, which we are going to see later. See, this is what I was talking about. The rope which is stretched along the length of the diagonal of a rectangle produces an area which the vertical and horizontal sides make together. Then, not only that, they have mentioned something that we call today as Pythagorean triples. That means integer values with triangles with integer sides, but by a square plus b square equal to c square. That is 5 square plus 12 square equal to 13 square, 8 square plus 15 square, and so on. So this mention of some, this is part of the modern number theory. Okay, to write formula for the primitive Pythagorean triples and so on. But these triples, at least some of them, were actually written in this Sulba-sutras. This is about computation of pi. So this is transformation of square into circle, and that gives some value. See, this is Sulba-sutra period, so about 700 years BC. The value of pi that they have come up with is fairly good. I mean, as compared to 3.146 and so on, correct value. And capitalizing on this work, our mathematicians of later generations could calculate the value of pi with further degree of accuracy, as we are going to see. But the work started very early. That's what I wanted to show here, that the computation of pi was started in Indian tradition very, very early. Okay, then in the post-Vedic period, so typically I come to now about 500 CE, well-developed science of grammar by Panini dominated this period. So as I told, that the tradition was around the Vyakarana and Tarka. So this period, so that was a very remarkable work, the work done by Panini. The work is in the book Ashtadhyayi, that formulates about 4,000 rules of Sanskrit morphology in a highly systematized manner. So this is one of the great works in Indian tradition in the field of Sanskrit morphology. And the peculiarity of this work is that this seems to be kind of very, very mathematical in nature, very, very systematic, in the sense that there is something very close to, one can call as place value system. So notational symbolism resembles with the mathematical methodology in this Panini's work. And place value decimal system, incidentally, came out in the Indian system in this particular post-Vedic period. So we saw that in Vedic period we had decimal system, but the place value decimal system, that is every number will have. This is one of the remarkable and one of the, I suppose, greatest contribution that came out of Indian mathematics. That is the place value decimal system. That is, any integer is expressible by using only 10 symbols, say 0 to 9. So a finite set is capable of generating an infinite set. This is a very remarkable thing, and thinking about such thing in about more than 1,500 years back, 2,000 years back, is remarkable, because the idea involves the concept of infinity. because you have been given only a finite set, 0 to 9, and you are generating any arbitrary integer out of it. And this is power of the recursive method. And that is the method I was talking about. So though not directly deductive logic is used like Greek mathematicians, the recursive technique is more prominent in the Indian system. So Indian mathematicians, they will take up some as initial value or initial set and build a loop, and that loop will give rise to an infinite set. So this recursive technique is apparent in geometry also, number systems also, and place value decimal system is one such example where one has to go to an infinite set from the starting with a finite set. That's what I was talking about. Indication of recursive techniques employed by Indians. So this is typical Indian technique, recursive methods. Then came Pingala, who wrote Chanda-sutras. All of you must be knowing about chandas. So poetry is written in terms of chandas. Nowadays we have mukta chandas also, but there are some traditional chandas in Sanskrit literature describing various poetic meters constructed out of. So Pingala asks 5 combinatorial questions. I have written again the modern word. Combinatorial means counting techniques. So how to count something? See the parallel development of mathematics and other cultural things like poetry, grammar. Okay, they go hand in hand. So their developments go hand in hand. So because of the development of the some mathematics in post-Vedic period, the entire thinking goes more and more in a scientific way in other areas of life also. So Pingala asked about how to construct or in how many ways a possible poetic meter can be constructed out of arbitrary given n syllables. Okay, so that's also very interesting. As I told, I cannot elaborate on one particular thing because one particular matter. So if one wants to talk about Panini, it will take more than an hour. One wants to talk about how this, what are those 5 questions, and what was motivation of Pingala and all that. It all will take much more time. So I am just indicating these matters here, and I will give references where will be able to see all the details. But let's at least see the amazing thinking pattern of Indians in a certain chronology that I am trying to develop here. One again finds the mention of the word sunya. So sunya is, or shunya as we call, or zero, is again can be found in Pingala's work also. A Buddhist cave in Naneghat depicts numbers in decimal form. Okay. And there is another Gwalior temple where clearly place value decimal system. So this is non-place value and this is place value. Okay. So 270 is written apparently in the encrypted in this cave, and that means clearly it's a place value system mentioned there. Now something that I call classical period, then that gives the evidences of advancement in astronomy. This classical period, roughly I talk about Aryabhata and Bhaskaracharya here and Brahmagupta. So I will talk about these mathematicians in this classical period. So lifetime of universe is estimated. Look at this, and then they call it as Kalpa, 432 into 10 raised to 7 years. Then this Kalpa is further divided into Mahayugas, Kali Yugas, and Manvantaras. There are 14 Manvantaras and 10,000 Kali Yugas and so on. So this period they further divided and try to distribute this entire, and this lifetime of universe is estimated in this particular way. Then computations are done in a unit called Yojana. So you will see this, how many Yojana. So Yojana is roughly about 8 kilometers in today's language. So you will see in this period this word very often, Yojana, especially in astronomical computations. Then institutionalization of mathematics took place in this particular classical period, where different schools of thought, they came together and form a kind of school or institute which they called as paksha. So these pakshas were formed. So this is particular period when they thought of actually mathematics schools have to be developed, though through Guru Shishya Parampara, but there were different schools of thought. So some kind of institution building was started in this particular period. So as a product of this particular system, and a prominent name is Aryabhata I, and he founded something called Aryapaksha about 500 BC and composed a very scholarly treatise called Aryabhatiya in 4 chapters, mainly devoted to astronomical computations and properties of sphere. But just as again sample, the quest of pi was everywhere there in Indian literature. Chaturadikam Shatamashtagunam Vashishtastata Sahasranam Ayutadvaya Vikashyasmasya Asanno Vrutta Parinaha. So Chaturadikam 100 plus plus Shatamashtagunam, you can decipher this shloka and you will get, now see the value of pi. This is advancement. Okay, that value 3.008 we saw in Sulba-sutras. Now look at this 3.1416. Much more accurate value has been calculated by Aryabhata. Then comes Bhaskara, one who was a commentator on Aryabhatiya and composed Mahabhaskariya and Laghu Bhaskariya. And another very scholarly book, Brahma Sphuta Siddhanta. Chapter 1 of this Brahma Sphuta Siddhanta is astronomical parameters. So there is more system in writing also. So now the texts are divided into chapters, okay, sections and things like that. So astronomical parameters and computation of mean celestial motions and positions. Chapter 2 is trigonometric functions, trigonometric methods for finding true celestial position. We'll get a chance to see this trigonometric table also in Indian methods. Very amazing values of sine function calculated in that particular period. Computing the apparent direction, place and time of celestial phenomena as seen from particular terrestrial location. Calculations for lunar eclipses in chapter 4, and chapter 5 calculations for solar eclipses. So this is Brahma Sphuta Siddhanta, totally devoted to astronomy. So anyone who is interested in astronomy, can go through these books. Now the English translations of these chapters or gist of these chapters in English is available. Aryabhatiya. This book Aryabhatiya was analyzed by Bhaskara, and it contains wealth of material. The first chapter, I showed you that there were 4 chapters. First chapter was totally on astronomy, but the remaining chapter had other arithmetic and algebra also. So first degree indeterminate equation. So what we will see that entire spectrum of mathematics was touched upon, not only just astronomy, but in Sulba-sutra we saw they studied geometry, purely geometry, geometric transformations, then mensuration, areas of geometric figures. Now comes algebra also. So first degree indeterminate equations, square and cubes in numerical as well as geometric forms, algorithm for square roots and cube roots, something that now we call as long divisions. Okay. Then area of triangle is computed again here as 1/2 height into base. Volume of pyramid is slightly wrong here. This area that is computed plus vertical height divided by 2, it should be divided by 3 here. Then area of circle, which is of course difficult because pi comes into picture. Okay, so half circumference multiplied by semi diameter, so that is correct, pi r square is correct, but the value of pi is evolved in the history. Okay, volume of the sphere is a root a, which is pi r cube root pi. They have mentioned a root a, where a is pi r square. It should be actually, the correct thing is pi by 3 pi r cube, but this we are talking about in the historic period in Aryabhatiya 500 BC. So fairly accurate value of volume of sphere. Then arithmetic progressions have been discussed in this 4 chapters of Aryabhatiya. some number theoretic modular equations. I am using modern terminology just to tell students that the A congruent to B mod n, and we solve equations by using these modular functions. Those equations were studied in Aryabhatiya to some extent, at least some simple computations are there. Then Bhaskara's commentary came in 629 CE. Now see this trigonometry that is considered in this Bhaskaracharya. So these are radius equal to 120 in the Pancha Siddhantika. Pancha Siddhantika is written by Varahamihira, and Varahamihira commented on this Aryabhatiya, and he gives how sine functions are computed. See, some important mathematicians I had to exclude. Varahamihira I can just touch upon in this particular way. See the last entry here, 90, 120. So all these entries of sine, you will see that how they are bigger than 1. Okay, because as we know now, it is normalized sine function. That is, sine values are between -1 and 1. But from 0 to 90, this table gives you values of sine. You have to just divide by 120 everywhere. So last entry is 120 divided by 120, that is 1. That is sine 90. Sine 90 is 1. This other entry in front of 30, you will see 60. 60, you have to divide by 120 because the value of r is fixed. So these are r sine values. So that is 1/2. So sine 30 is 1/2 is also correct. Values of sine are calculated, and very in between things also 14.15, 45 degrees and so on. So if you divide 84.51 divided by 120, you will get approximate value of 1/√2 because that is sine 45. So in this table, sine 45 is given, and from that you can compute approximate value of 1/√2. Come Brahmagupta in 7th century Christian era, author of Brahma Sfuta Siddhanta, first 10 chapters on astronomy. Chapter 11, analysis of Bhaskaracharya's work. Chapter 12 is on number theory. Chapter 13 to 15, astronomy again. Chapter 18, algebraic equations, especially solutions of quadratic equations, nx square plus 1. This is something called Pell's equation now, and this is solved in this set of integers. Okay. So you go to now. This is something a different topic in the sense that this is kind of isolated work carried out in northwestern part of the country called Baksali manuscripts. These Baksali manuscripts were buried in a field somewhere in the northwest part of the country, and it was found by a farmer in his field, and then it reached the ideologist ARF Indologist, should be AFR Hornell, presented it to the Boulderian Library at Oxford, and this is still there. This Bakshali manuscript, original copy, is still there in Oxford. Application. This Bakshali manuscript especially contains the applications of the arithmetic and algebra in physical problems. So some actually physics problems or the chemistry problems like alloy and contents of that alloy and finding proportions and things like that. So these actual applications of the mathematics developed in physical problems can be found mainly in these Bakshali manuscripts. Again, you will find a lot of literature on this. I'm going to give you reference. So let me touch upon this and give those who are interested can go through. Each and every topic is worth studying. If you look at just Aryabhatiya, then Aryabhatiya can be a lifetime passion. Bhaskaracharya, you can take up Bhaskaracharya, completely decipher it. Okay, in fact, the students are urged to take projects or interest in this ancient Indian mathematics. Take one particular topic and then dig up the matter. Okay, now a lot of material is available. Bhaskara that we talk about now, he comes from Maharashtra. It says that near Chalisgaon there is a temple also, Bhaskaracharya temple, and he is known as Bhaskaracharya. Very famous name now. In fact, we have an institute in Pune, very famous institute, works in field of mathematics and caters to small students up to research. So a very peculiar kind of institute which caters to the interest of school going students, especially in math olympiad type mathematics. So there is some coaching in maths olympiad, plus some undergraduate postgraduate level programs, and also research program is there in Bhaskaracharya Pratishthan. So that Bhaskaracharya is this Bhaskara too. So in his writing, you will see a very high degree of sophistication. And he wrote three very famous texts. Lilavati is very famous among the maths lovers. Siddhanta Shiromani and Vijaganita. He was the first mathematician to get a wider recognition. His writings are on the walls of the temple in Maharashtra. His roughly, one is not sure, but some photograph is available. Then inscription in a temple, as I told you. There is some project going on in Chalisgaon, I heard, where this Bhaskaracharya school is trying to develop the mathematics around Bhaskaracharya right in the place where he was born. The main contributions comes with arithmetic with fractions now, word problems to be solved algebraically. In Lilavati, you will see many word problems and in conversational manners. So, a disciple asks something and Lilavati asks something, and the teacher answers. So there are solved. There are word problems. Okay, corrections in formulae for area and volume. So we saw there was some minor correction there needed in the formula for area and volume, and these formulae are corrected in Bhaskara's work now. Solutions of algebraic equations to the extent of degree 2 can be found in this. Then linear simultaneous equations, as we call now, their solutions can be found in Bhaskara's work. Siddhanta Shiromani is totally on astronomy. Lilavati is a famous book, so I will just keep this slide in front of you, and verses by verse, I have given you the brief contents. This book is also available, and interested students can go through. Very simple book, but very insightful, and especially the period that we have in mind. It is remarkable that how Bhaskaracharya came up with all these methods. Rule of three, then series formula for sum of first n integers 1 plus 2 plus 3 up to n, and we know famous stories of Gauss, but Gauss is what, 18th century, 19th century. So this is just 13th century mathematics. Geometry of triangles, and 3927 by 1250 is the value of pi that is given here. Okay, Euclidean division, solution for linear indeterminate equations. Okay. Then let's come to Kerala school that Sukumarji was talking about. So this is another very, very interesting episode in ancient Indian mathematics. It's relatively new as compared to the Vedic period. So you can see 1350. So it is 14th century mathematics. But when I also heard about Madhava and his work, I was amazed because it is about 250 years of oral tradition. In Kerala, Sangamagrama, as Sukumarji was telling, and Guru Shishya Parampara, and not just for 1 or 2 or 50 or 100 years, about 250 years long tradition of mathematics. Really amazing and very, very interesting and great mathematics has come out of this Kerala school. So you can see Madhava, his disciple Parmeshwara, then Damodara, Nilakantha, Jeshtadev, Shankara, Achyut, Narayan, galaxy of mathematicians. And if we look at their work, just a few days back in course called Mathematics for Everyone, I delivered full 1 hour lecture on only Kerala school. There is only Madhava and all these other disciples, their work and contribution of Madhava. So this is again, that 1 hour is also not enough. If one wants to give full justice, one should talk more about them. I also gave a public speech in Pune in Marathi just to popularize Madhava among masses, and that was organized by Marathi Vijnana Parishad. So that was also full 1 hour lecture, but completely in Marathi about Madhava, where I gave proof of the proof. I gave means I showed Madhava's proof to the audience of Newton Madhava series or Newton Leibniz series, classically called. But now one can say that it was derived initially much before Newton and Leibniz by Madhava. So they started. Their motivation was from our ancient mathematics, that is Aryabhata 2 and Bhaskaracharya 2. So he is commenting on their writings. So there is no direct evidence by writings by Madhava, but all his disciples have written that Madhava has said this. So the credit always goes to the initiator of the school, Madhava. Then Parameshwara, only student of Madhava, who produced 25 volumes. So Parameshwara was a prolific name in this Kerala school, and especially mathematics and astronomy. Mathematics means again some algebra and number theory, plus mainly astronomy. Neelakantha, who wrote the book Tantra Sangraha, and that completely analyzes the Aryabhata 2. So Aryabhata 2's work, if you want to see in a detailed version, then it is worth going through Tantra Sangraha. And now English translations of these books are available. Okay. One of the most important books in this Kerala school is Yukti Bhasha, where you have detailed proofs of all the methods employed in the Kerala school. The one I was talking about, the recursive method, you will be able to see very, very prominently used in Yukti Bhasha, and explained how Indian tradition revolves around this particular method in all the fields, not only place value decimal system, but also in geometry. Even in the proof of this Newton-Leibniz formula, this kind of recursive technique is used. So Yukti Bhasha is also now translated in English, and definitely I will urge all students to go through it. Then Yukti Deepika and Kriya Kramakari based on Lilavati. So they wrote mathematics based on their earlier mathematicians. Also, great amount of new mathematics. And the new mathematics, which is very amazing, and I always feel that it should come out of in front of world, is the calculus that they invented much before Newton and Leibniz. So all the science students still think that calculus is from Newton and Leibniz, and perhaps they invented it on their own. I mean, one is not very sure about the transfer of knowledge from one place to the another. But in any case, it was invented in India before Newton and Leibniz in this particular Kerala school. And David Mumford, a great mathematician, modern days Fields medalist, he writes that it seems fair to me to compare Madhava to Newton and Leibniz. So this is review of Kim Fokler's book. So definitely it is very clear also that Madhava came up with all the important ideas of calculus, main two ideas of differentiation and integration. And the culmination of these two in the fundamental theorem of calculus is also there in Madhava's work. The work remained unnoticed, perhaps because it was carried out in a corner of the country and written in Malayalam and Sanskrit. So it remained unnoticed. Historians started paying attention in last 50 years only. And now look at this, just as a highlight, just one particular piece I want to show you. All these words are appearing in this shloka, and these words have to be deciphered in this particular. Vibhuda means 33, Netra means 2, and so on. But once you do all that deciphering and write the value, then this value of pi is accurate up to 11 decimals, which is extremely great compared to about 700 years back. Computing value of pi up to 13 decimal places. It is clearly written there, and there is no ambiguity in whether they have found or not. It is very, very clear. And the proof of this series is there, which we used to call as Newton-Leibniz series. So 1 minus 1 by 3 plus 1 by 5 minus 1. These are alternating series. and all the mathematics students know that it converges to pi by 4, and therefore if you multiply this by 4, you get pi. So this entire series is pi, and now if you want to compute pi, you have to truncate this series somewhere and then actually compute that right hand side and find the value of pi. Of course, the slow convergence will give you, I mean, if you want to find 10 decimals, you may need to go up to 1000 terms in the series. But in any case, as pure piece of mathematics or mathematical analysis, one can say, this is a great achievement. Not only this, they came up with many geometric series, trigonometric series also. So series expansion, which is main thing in analysis or calculus, has been done in Madhava school, and by using differentiation, integration, and fundamental theorem. So all the essence of calculus was already there, and it is clearly there. There is no ambiguity as such. Okay. I was telling you the importance of decimal value place system, which is employed, or recursive methods employed earlier and also in Madhava's work. So look at what Newton says. The ingenious method of expressing every possible number using a set of 10 symbols seems so simple nowadays that its significance and profound importance. The idea of expressing all quantities by 9 figures, thereby is imparted to them both a position and absolute value, is so simple that this very simplicity is reason for not being sufficiently aware how much admiration it deserves. And this was done when? This was done in post-Vedic period, Aryabhata 1. Okay. So this, what Newton talks about as which deserves great admiration, and it is one of the very, very significant facts in mathematics, comes from Indian tradition, and we are all proud about it. And towards the end of my lecture, as I said, I will touch upon Ramanujan. Again, Ramanujan, one can give series of lectures. Okay. But in this lecture, just to tell you that the high point of Indian mathematics came in the Ramanujan's works. The greatest mathematical genius that world has ever seen, produced miraculous mathematical masterpieces despite the lack of adequate facilities and substantial training in higher mathematics. He did almost everything that modern mathematicians wanted: infinite series, continued fraction, distribution, and he carried out all this work in a particular modern fashion, but in his own way, because he was not a conventional mathematics student. Elected on London Mathematical Society, youngest fellow of Royal Society. So Ramanujan is a miracle, and one person who showed rest of the world that what Indian mathematics is all about, how Indian mind is already very matured in mathematics. That comes in the work of mathematics. And of course, maybe Hardy found him and took it to Oxford and all that, but everybody agreed that he's the only mathematician who is a mathematician from within, from system. He is not constructed mathematician, constructed in schools, colleges, and universities. He is a born mathematician and one of the greatest figures that world has seen in mathematics. Just to tell you all the stories, all of you know 1729, sum of two cubes in two different ways. So I will not go into this. I will just show you this. Some problems from mathematics. Ramanujan's notebooks are still unresolved. Continued fraction, again, one single topic is worth talking for a long time, but I just wanted to give you highlights. So if you stop at only 7, suppose, then it is 3 plus 1 by 7, that is 22 by 7. But you may stop at 15, then you will get more accurate, and so on. So this is infinite continued fraction which gives exactly pi. See, if you stop at 15, you will get 333 by 106. This is very unusual formula approximating pi, and only Ramanujan can think about such things. So he worked in the field of magic squares also. So just 22/12/1887 is his birth anniversary, birth date, in fact, 22 December. Just after 2 days we'll celebrate, or on the day when this festival is going to be opened by Honorable Prime Minister, that is 22nd December is Ramanujan's birthday. In fact, I will talk on Ramanujan on that day in a national webinar organized by Gujarat Ganit Mandal. That will be lecture only on Ramanujan. So to end the lecture now, let me just conclude by saying that Indians never used method by contradiction. That is, suppose the result is not true and then arrived at a contradiction. They always try to give constructive proofs. So start from the data and go towards the result. And basically by, capitalizing by earlier step, then go to next step and things like that, rather than deduction by recursive methods. So slightly different logic is used. Then naturally encompassing the notion of infinity, which I talked about. Then researches in all areas of mathematics: astronomy, algebra, geometry, number theory, infinite series, etc. What is needed is that we need for a scientific study of historical evidences. See, we are all very proud of this, but at the same time, we now, by this time, we do have books, literature, translations, evidences. So today's students must go through these historical evidences, and then something that is historically proved, like Madhava's mathematics or all the mathematics that I talked in today's lecture. We do have historical evidences. We can clearly say that our mathematicians have done this. Once we do that, then we need to have collective efforts in popularizing Indian mathematics. That go ahead, tell others, write articles, give speeches, okay, try to incorporate in school studies, okay. So wherever calculus comes for the first time, we should write in textbooks that this was done by Indian mathematician Madhava. It will go in the formal system then. So we know collective effort means efforts on the parts of people as well as government and many official bodies and maths lovers, mathematicians, and so on. But before that, we need to first of all very scientifically study the evidences and then go for this popularizing. We are all proud of the contributions, enormous amount of contributions that Indians have done in this field of mathematics. So these are some references. This first book contains in detail the proofs as well as all the study material that one wants to start with, and then use the references in turn given by Kim Faulkner. Very scholarly book and on mathematics in India. Then Divakaran, who studied Kerala school very minutely. Then Professor Dani, myth and reality. I was talking about we need to study very scientifically first and then go. So you may go through this article related to that point. And on Ramanujan, several references, but G.H. Hardy has written a great book which has 12 lectures on Ramanujan published by Cambridge University Press. Thank you. Thank you very much. That's all I wanted to talk about.
Yes, thank you so much, sir, for this very nice lecture. I'm very much sure that many viewers must have come to know many new things, and it was basically like listening to a mathematics story from you. So it was very wonderful. So now I request Arvi sir to propose vote of thanks and end this session.
It was an enjoyable, beautiful lecture, I will say. It was very enlightening. In fact, many of us have been knowing the things superficially, but not in details that he has covered. In that sense, it was extremely enlightening. And it was very consistent with the theme of Vijnana Bharati, that we always take pride in the ancient things and we want to study the ancient things in the modern framework. So that part also he has covered extremely nicely. And definitely we will encourage the students to take the study of this mathematics in the ancient times. And in fact, many people can take it as a research also and get the PhD in that also. So it makes us proud of Professor Sholapurkar. It's our luck that we had him with us today. And I'm sure he will be associated with us now onwards also forever, because
Sure,
he is
sir.
the one. Yes,
I have
thank you,
been
sir.
associated with Vijnana
Yes,
Bharati for
you are.
years ago,
Yes,
and
yes. You have already attended our programs. I remember it. Hmm?
I will be
But
happy to join in future also. And whenever
Yes.
Vijnana Bharati calls me, I will be there always.
Thank you. With your guidance, we can do a lot of things. So
Thank you.
thanks you to once again. Thanks also to Sreeprasad ji for enlightening us on IISF. And we will end the program with Shanti Mantra. Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschid dukkhavag bhavet. Om Shanti Shanti Shanti. Thank you everybody.